and welcome to session 11 of Virtual OTEC 2020. This session's title is Transportation Innovation, and I'm Victoria Beal with the LTAP Center, and I'll be your technical support behind the scenes. A few housekeeping items before I turn things over to your moderator. Questions will be accepted throughout the session in the question box. We'd like for you to please look for the question box if this is your first session with us, or if you haven't yet used it. And the question box is in the GoToWebinar panel. Please drop us a hi or hello in there so we know you found it. And please note that we will not be accepting questions via the raised hand feature because there are scheduled to be a complete 1,000 people on this presentation today. So please use the question box though throughout the presentations. The session is being recorded, and if the technology cooperates, we'll post a YouTube link to the video on the OTEC site once the complete conference is finished. So that'll be after the end of next week. Also, after the end of next week, you'll be receiving a certificate which will contain 1.5 CPDs for your complete attendance at this session. So if the session runs over, that certificate is not going to be modified to include any additional time, but we do encourage you to stay on if the session runs over. Just note that the 1.5 will not be increased. So with that, I'm going to thank you for your attention, and now I'm going to turn things over to Luke Stedke.
Thank you, Victoria. My name is Luke Stedke, and I am the Managing Director for Communications and Policy at DriveOhio. Welcome to our webinar. We are overwhelmed and excited for the support that we are seeing currently. To start us off, we have Howard Wood. Howard is the Executive Director of DriveOhio. He has over 30 years of transportation experience, both in the public and private sector. He is our guru of all things innovation. He has degrees from The Ohio State University and Rutgers. It is my pleasure to introduce Howard Wood.
Greetings. Thank you very much, Luke, and happy to be here at this Transportation Innovation session. Luke and I were going to start off with a little bit about DriveOhio, which tees up a lot of the activities we're going to hear about today. And so the first slide, Luke, I know that there's going to be a delay, but so why DriveOhio? On the left, you see some federal highway rendering from the 1920s or so. And we're really in the midst of a revolution whereby previously we designed roads around a system where there's a car and a driver, and everything was governed by the driver's reaction time, the sense, and to react to the environment around him or her. And so we're moving into obviously a time with much more technology in the vehicle. You see that on the right. If the vehicle has, you know, blue neon, it's got to be high tech. That's just how tech works, right? But seriously, you know, we're talking about cameras, LiDAR, radar, ultrasound on the vehicle, and a potential for a vehicle to be processing 1 to 15 terabytes of data per vehicle per day. So this is happening, and this is why DriveOhio exists. Next slide. As we travel the state, or as it were, sit in my bedroom, doing this work, we always get the question of when is this going to happen? And some of you are familiar with the levels of automation from SAE, from 0 to 5, which 5 is full automation. And you know, to an extent, we're in the middle, and the future's already here. It's just not quite everywhere. So we do have a lot of systems that are helping the driver. Anti-lock brakes has been around forever, but more and more features are coming into the vehicle and assisting in what we're doing. And of course, on the level 4 and 5 side, we have tests underway in places like Pittsburgh and Michigan and California. So the future is here, and that's what DriveOhio is concerned with. Next slide, Luke. So The vehicle environment we see on the left, there's a technology revolution I mentioned underway, and a propulsion evolution with probable shifts to more hybrid and electric. And on the right, there's potential for different vehicle ownership models, Uber and Lyft, and just maybe not owning your own vehicle. And of course, any of these will have some possible impact on public infrastructure. So that's the why. That's why DriveOhio exists. And on the right hand, the column, I'm not going to read them all, but you get to some of the things that we're concerned with. We're testing automated vehicle corridors. We're interested in the policy angle. So these are the portfolio of DriveOhio, and essentially, if we could just summarize it, we have DriveOhio, and we have the unmanned aircraft system center for our drone operation, and we exist as basically a policy shop to test and develop the policies for the state that are going to be needed to deploy these widespread. So with that as just a brief introduction, I'll turn it back to Luke for the next segment. Thanks.
Thank you, Howard. Howard mentioned, I will take a little bit deeper dive, just a project overview. And you can see on this slide, as he indicated, we are on the ground and in the air. We were reauthorized in October, actually a year this week at OTEC with the governor and Director Marchbank stood on stage and reauthorized DriveOhio as the one-stop shop for automated connected vehicle technology in the state. And you can really see through this slide, the one thing, there'll be two things that'll really come through, I think, all of our presenters today, is the importance of partnership. That's a through line, and also the ability to leverage an ecosystem that we believe is unmatched in the United States when it comes to the development of automated and connected vehicle technologies. As Victoria said, there is a little bit of a lag on we've got a full group of about 1,000 people, so we appreciate your patience. And here in this slide, you see that ecosystem. On the ground, we have the Transportation Research Center. Unlike any other testing facility in the United States. And then also in the air, we've got the Sky Vision asset at the Ohio UAS Center. We have partnerships with NASA Glenn. We have partnerships with the Air Force Research Laboratory, Wright-Patterson Air Force Base. We talk a lot about the design, test, deploy ecosystem in the state of Ohio. You also see some projects. Nick's going to talk a little bit more in detail about the 33 Smart Mobility Corridor. Two new projects, the Deploying Automated Technology Anywhere, that's the data project, that's ADS, our Automated Driving Systems grant that we were awarded last year. And then we're going to have, you'll see in the slides here, we'll talk about our I-70. We have stayed busy during these unprecedented times. We submitted our inaugural DriveOhio report to the governor's office, and it's a good way to get the Smart Mobility 101. You can see when we start talking about smart mobility in the state of Ohio, you can start talking about 2005 and 2006 with the DARPA challenges. We talk about 2016, the Smart Columbus win, and also the 33. That's when ODOT wins the ATC MTD to put the fiber and the thoroughfare. So a good overview, good piece if you want to learn more about DriveOhio and a little bit more granularity. City solutions. We talk about 5 focus areas, one of those being city solutions. You can see here on this slide, give it some time here, the Linden Leap, the autonomous shuttle that started in February of this year. I had to do a little bit of pivot. That's one of the things that also is very important when we're talking about smart mobility, the ability to have a thesis, to learn on the fly, use data to inform those decisions. And like in this case with the Linden Leap, the pandemic was not going to allow a deployment which was original to scope. So instead of moving people, they're moving food between 2 locations in Linden. It's another example of smart mobility, being able to pivot and solve local challenges. And here we have the flagship, the US 33 Smart Mobility Corridor, 35 miles of connected and automated ecosystem. You can see the partners there. It's both on the ground and in the air. You know, Fred's going to talk a lot about the air side. Nick's going to talk about the ground side, but it really is, as these technologies mature, we see them coming together. Over the next 5 years, there's going to be a lot of opportunities and development, some of which the opportunities came from the current situation of what we're working through right now. But again, partnership is paramount. You've got Union County, the city of Marysville, city of Dublin, TRC, DriveOhio, and FlyOhio. So it's that complement, that ecosystem of partnerships that we can leverage to help solve and deploy these solutions. A little bit more information about our ADS win. When you look at the development of specific to automated vehicles, a lot of it takes place in urban areas. So USDOT wants to get data about more rural applications, and this is our project fit that bill very nicely. We will get started here, working towards deploying these systems in a more rural setting to figure out what the infrastructure needs to have improved. If there is such a thing, we'll be doing a road audit to see what type of improvements to the infrastructure need to be made for the technology stacks to read, to make sure that we are focused on safety. That's the one thing that at the Ohio Department of Transportation we are always cognizant of, is the safe deployment and the increased efficiency of our system. So look for more of that at the end of this year and the next year. Another rural application is our roadmap project, coming on the heels of the ADS one. This focuses not only on electrification, but also automation, and see how, again, that rural setting for these technologies, how they are employed and how they can be employed and utilized most efficiently. The I-70 truck automation corridor. If you look at the Venn diagram, we talk about partnership a lot, and this is what we're seeing here. We think the triumvirate of operators, being the host fleets, the infrastructure owners, that's being the state DOTs, and then the technology vendors, that brings together a three-legged stool that's going to help make these systems more robust, make sure we are solving problems that the industry and the community see value in solving, and then also making these systems interoperable. The real secret sauce of this one is the interstate cooperation between the logistics councils and the state DOTs, Indiana and Ohio, and of course TRC, and the importance of the U.S. Department of Transportation, of course, is always forefront of mind. Some more, this is the Automated Vehicles AV Pooled Fund. This is kind of a thought leadership, this is thought leadership. This is a program that is we're calling it the crossroads of America, I-70 and I-75. The amount of people and goods that travel through those two thoroughfares is unprecedented. It's a major thoroughfare, east, west, north, south in the United States. So taking that partnership between other state DOTs that are thinking about this in innovative ways, we hope to suss out, develop, whether it's deployment standards, whether it's interoperability standards, just to start a conversation with multiple states focused on automation and deploying these across the nation. And then our second policy piece is the electric vehicles charging study. On the right, you can see our corridor-based approach to that. We set this out in June of 2020. Again, partnership key. We had a working group with Public Utilities Commission, the Ohio EPA, DSA, ODNR, Public and Public Safety, everybody coming together to help develop a statewide strategy to electric vehicle charging. Now, we know from a state perspective that the state is not going to build out these systems, but we wanted to put something out there, a resource for local communities across the state to kind of learn about, electric vehicle charging, see what our initial recommendations are, and then go from there. So a good piece if you want to learn more about electric vehicle charging. And again, thought leadership, DriveOhio was lucky enough to be part of the AV test initiative through NHTSA. We also have a great partnership with PAVE. These are two ways that we can engage with industry and government to facilitate conversations around automated and connected vehicles on the ground and in the air here in the state of Ohio to kind of reinforce our leadership position when we're talking about national standards and deployments. So with that, it is my pleasure to introduce Fred Judson. Fred is the director of the Ohio UAS Center. He is our ace in the air, as we like to say. Fred has been an ODOT employee for over 26 years. He has leadership positions on aerospace and unmanned aircraft systems across the United States. I was talking to one of his colleagues today. I think he's going to be presenting something in Portugal either this week or next. So Fred is a leader when it comes to unmanned and advanced air mobility. It is my pleasure to introduce Fred Judson.
Fred, you're still muted, so you're going to need to unmute and restart.
Sorry about that. Thanks, Luke. As Luke mentioned, I'm the fly side of DriveOhio. We are focused on all advanced air mobility, so it doesn't necessarily have to be unmanned, but it could be optionally piloted aircraft as well. The first slide is showing FlyOhio, and we formed FlyOhio because we know that there's a lot of stakeholders in this new, it's called the third revolution in aviation. First being the Wright brothers, second being jet aircraft, and the third is the electrification. And then diving deeper into electrification and aviation, we can get into vertical landing and takeoff aircraft. And it is our job to support those technologies and help them prosper within the state. So you see all the different organizations that belong to FlyOhio, and we all try to move together as one with the new advances in aviation technologies. Next slide. Luke, can you advance next slide? So just some awards and announcements that we've had over the last year. We were ranked second for aerospace attractiveness as a state in the nation by PricewaterhouseCoopers. Also mentioned in there is our efforts in advanced air mobility technologies. The next image is our we actually won the AVSI Excellence Award that was just announced a few weeks ago. And the last one is our award for SkyVision for the Air Traffic Controllers Association for innovation. Next slide. So getting into, again, what we see, there's a lot of parallels in the technology that's on the ground and the stuff that's happening in the air. I know flying cars is sometimes a hard concept, or flying trucks, if you get into logistics, is a difficult concept sometimes to grasp. But this technology is happening. The picture at the top is our SkyVision asset, but I'll go into more detail later. But we get into particularly logistics. We're looking at larger vertical landing takeoff aircraft that will eventually be autonomous, that will feed our main logistics hubs, and then do smaller logistic hubs. And then I'll get into a little bit more in detail on last mile package delivery, which we are also supporting. And that was a nice quote from one of our package delivery people that are testing in our SkyVision asset that you see down there from Telegrid. Next slide, Luke, please. So getting more into detail, for those that don't know, SkyVision is an asset that's located at Springfield Beckley Airport. It was a partnership between us and Air Force Research Labs that are housed out of Wright-Patterson Air Force Base. We use this asset to safely integrate unmanned aircraft systems or optionally piloted vehicles into the airspace. So there's a lot of testing that's going on all the advanced air mobility concepts at the Springfield Beckley Airport using this asset, and that is the asset that won 2 of the awards that I mentioned previously. Next slide. As you can see, this is the inside. The control centers on the right. They're where we have our operators. We have operators on staff that are able to sit there and make sure that, you know, when these systems are in the air, that they're not going to pose a danger to any of the other aircraft that's in the airspace. Next slide, please. So this is the volume of airspace. We are one of the only locations in the United States where we can actually perform true beyond line of sight operations with unmanned aircraft. It's a volume of about 200 square miles from 1,000 to 10,000 feet. We are able to put an aircraft up, and what separates us from the rest of the country is we can actually perform tests beyond line of sight without any observers and any aircraft of any size, which is one of the unique capabilities that Ohio has, and the reason for a lot of the development work that's going on in Ohio, supporting the advanced aircraft mobility technologies. Next slide. And this is just a zoomed in, and probably most of you probably aren't aware of what air traffic controller screens look like, but this is very close to what a traditional air traffic control looks like. And this is the, you know, when there's an unmanned aircraft we have up in the air, this is showing some of the other aircraft that are in the airspace, and how, you know, our controllers, when they sit there, they're able to deconflict any potential threats that may come close to our operations. Next slide. Before I get into unmanned aircraft traffic management, I do want to say that in the SkyVision asset, you know, we are performing aircraft of operations of aircraft of all sizes, supporting not only supporting logistics, small package delivery, and the larger logistics type aircraft. They're able to do short, medium, and long haul operations, but also the movement of people, which again, we get into the flying car concept, which I'll talk a little bit more about. Another research project that we have with the help of our Office of Research is the Unmanned Aircraft Traffic Management System. Currently, the configuration is 3 radar installations along the 33 Smart Mobility Corridor, working with our ground transportation systems. That's our goal for this project is to do beyond line of sight unmanned aircraft operations along that corridor with these radar installations. And there's some exciting new developments that before I get to the end of this that I'll talk about. But this is allowing not only just long range data collection type activities, but also package delivery, which we'll get into in the next couple of slides. Next slide. So one of the uniqueness about this research project that does separate us again from the rest of the other areas in the U.S. that are doing this type of research is our interaction with the unmanned aircraft and our ground connected vehicles. Realizing that we've got a large investment along the 33 Smart Mobility Corridor, we wanted to see where the intersections of the air and ground and where they meet. So that is one of the uniqueness of that research corridor, and one of the things that separates the Ohio from the rest of the states. Next slide. Okay, and before I actually get into NASA, I do want to say that the exciting changes to the Unmanned Aircraft Traffic Management Research Project is the fact that we will be moving one of our radar installations to the top of the ODOT headquarters. So you'll see in the very near future, our radar is sitting on top of there supporting last mile package delivery, supporting a medical use case in Columbus. So that's an exciting advancement and something that you will be reading about in our press releases in the coming weeks. Can you go back one slide, Luke? So some other ways that we support advanced air mobility is with NASA. So we're currently working with NASA Glenn and assessing where these vertical landing takeoff aircrafts will eventually be taking place, whether it's in urban or rural environments. So we are working directly with NASA Glenn on analyzing our urban centers for potential vertical replacements. And those of you who are in the audience, if you are one of those individuals, in an urban center, we've either are reaching out to you, or we will be reaching out to you as far as helping NASA help develop their tools to look for potential vertical land takeoff locations. And these may be supporting logistics, or they may be supporting the movement of people, but it is really the larger aircraft and vertical landing takeoff aircraft that'll be taking place in the urban centers, and working with them on what that future of that airspace will look like. Next slide. So getting into some other efforts that are going on, and I'm going to talk a little bit about Agility Prime. Agility Prime is again, we're focusing on the electric vertical landing takeoff aircraft for the movement of people and goods in the airspace. Agility Prime is an Air Force initiative, and what the Air Force realizes that private industry is advancing this at a very staggering rate. And so what they're looking at is potentially reaching into the commercial side and repurposing some commercial vertical landing takeoff aircraft for DoD type purposes. In return, the R&D money that will be provided through the military's testing would then feed the commercial sector and help push the new technology into normal day-to-day activity in the near future. So what they're calling vertical landing takeoff aircraft, they're terming it orbs. That's why that orbs is there. Whether orbs will stick as the term to be used for vertical landing takeoff aircraft, I'm not sure. That's yet to be seen. That being said, again, Agility Prime is actually housed out of Wright-Patterson Air Force Base, which is 30 miles from Skyvision, which is why you'll see a lot of Agility Prime activities taking place at that location, and directly using the Skyvision asset. Next slide. So getting into some of our other projects that we have a 36-month economic impact analysis. Oh, no, I'm sorry, this is the pooled fund. We have a pooled fund request out there looking at vertical landing takeoff aircraft for the movement of people and goods within the airspace. We made it a pooled fund study because we are focusing on the I-75 and the I-71 corridors, connecting our urban centers and major thoroughfares for logistics. It will focus on interstate commerce, on what the new vertical landing takeoff technologies will do for us, with demonstrations taking place of the movement of people and goods with the new technologies between Columbus and Dayton. It is a 36-month study that will be taking place. We currently have backings from Texas and Michigan. We've got about 5 other states that are looking to join us. Once we meet that $2 million contribution, we will be this project will kick off as an official project, and we'll be reading a lot more about what happens after that. Next slide. We are excited to announce a 6-month study for the economic impact analysis for the state of Ohio with all the new vertical landing takeoff aircraft technologies. That's going to be headed out of the University of Cincinnati with Crown Consulting. Again, a lot of stakeholders are probably in this meeting right now, and there will be a survey that will be sent out in the coming weeks on advanced air mobility technologies and what that means for you, as well as stakeholder interviews. So what we're hoping to gain out of this research project is trying to assess what is actually going to happen for the state of Ohio. NASA and the FAA have produced their own studies, but that was for nationwide. What this study is going to do is kind of mimic what NASA and the FAA have done, but actually get into the Ohio as the focus and produce what we will need as information as we move forward in our planning efforts. Next slide. Last one is a 24-month study that we just proposed for a research project. That will be the looking at taking, it's a combined sensor network. What we have is a bunch of, as the Department of Transportation, we care about enabling this technology, and there's a lot of others that are installing sensors around Ohio, looking at the lower altitude airspace. And we are proposing for a combined lower altitude framework where we can take all these sensors and then bring them to a clearinghouse to meet all the needs for all the different entities that, whether they're airports, our Department of Corrections, or the Department of Transportation, or any other potential stakeholders, that we might be able to leverage everyone else's investments and move together as one Ohio. So we're excited for that project as well. And I think that was my last slide. Oh, and then the combined slide with Fly and DriveOhio, and us moving together, whether it's connected on the ground or in the air, advancing all the new mobility solutions that are out there. And that's all I have.
Okay. We're going to switch over presenters here. Bear with us.
No?
So it is my pleasure to introduce John Puente. John is the Chief Data Officer and Administrator of the Data Governance Office at ODOT. His office manages data policy, rules of engagement, and enterprise data standards utilized by the organization. John's office also oversees the collection of detailed business requirements, in-house application development documentation, and manages the ancillary assets for ODOT's Transportation Asset Management Program. It is my pleasure to introduce John Puente.
Thank you. Thank you. All right, so thanks, Fred. That was a great presentation, as always. As you guys have witnessed, we've seen some amazing efforts dealing with technology at ODOT being presented as part of this session. And there's actually more to come later in the hour. What I would like to do today is to help you to understand the value of data as an asset at the Department of Transportation, and at the same time, to make you aware that there's an obligation at ODOT to manage the information we collect or that we provide access to. ODOT publishes and continually updates critical success factors every few years as we outline the strategic direction for the organization. It's undeniable that the safety of our traveling public, the movement of goods, and the reliability of the quality roadway network are always at the forefront. So then ask yourself, how do we usually or actually make these decisions to help to support those goals? And as you well know, there's a number of factors that enter into how we base our decisions. But I think that we can all agree that the quality data transformed into reliable information should be the basis of making any major decision at ODOT. ODOT's invested billions of dollars in our infrastructure assets and continue to maintain excellence of our road network to the tune of $2 billion a year in construction projects. That's a substantial investment in our physical assets. So now we should ask ourselves, what is that next step in making decisions to meet future needs? Well, the answer is tapping into the technologies of tomorrow, today, and making the best of the data we have at our fingertips. That statement in itself makes data not only a key part of the infrastructure at ODOT, but more importantly, one of our most valuable assets at the organization. You know, as state employees, we often strive to be good stewards of taxpayer dollars. And we've realized that we can't build our way out of congestion in every situation. You know, especially now in these times as funds become more limited due to less travel during the pandemic, right? So now what? Well, for ODOT, it's actually utilizing data to its capacity as the answer. The introduction of real-time data analytics lends a need to process and store a vast amount of data at a much higher rate than ever before. ODOT and local government agencies alike are providing smart corridors and physical infrastructure to meet future data needs, and in turn, the higher volume of data that's being collected as part of it. So that being said, there's an opportunity here to not only provide better service to our customers, but to also manage and protect the data that we deliver in our final products. And that's where data governance comes in. I want to take a minute and show you a short video that we put together to help communicate not only the effectiveness of data governance at ODOT, but also the importance of to the organization, I should say. So give me just a second to get that launched.
You know about our roads and bridges, but one of ODOT's most valuable assets is data. Now, you may not always be able to see it, but our state and local engineers, planners, highway and construction teams use it every day to make smart decisions. Because it's so important, we must find better ways to capture, manage, and share this data, internally as well as with our transportation partners. That's where data governance comes in. It's the overarching policy and procedures for ensuring and managing massive amounts of quality data, and it's the foundation for making better decisions while protecting your privacy. You see, ODOT collects, acquires, and enters data in many different systems, allowing others to retrieve the data they need for their own analysis. We enter vast amounts of data about our transportation system, like roads, bridges, maintenance, and safety. This allows us to spot and fix problems quickly. For example, our safety experts analyzed our data on why there were so many cross-median crashes. The solution? Ensuring the use of quality information. We installed cable median barriers in those hot spots, and cross-median crashes dropped by 95%. Now, we're not bakers at ODOT, though we do love our carbs. We're doing something much more important: saving lives. Like a baker, we should start with a good recipe and clean quality ingredients, which are ODOT's new data governance policies and standards. We're creating a data cookbook to manage information in our systems that everyone has access to. Now, instead of a delicious loaf of bread, we mix massive amounts of data to produce targeted projects and services to save lives and money. Better data drives better decisions and a safer tomorrow for everyone.
Okay, so after viewing the video, hopefully you get a sense of what we're trying to accomplish by managing data at ODOT. What you see before you now is actually ODOT's definition of data governance that follows a framework that we established by which we manage the program itself. So essentially, we're striving to provide good data that's both secure and of quality, and as well as integrable with the other ODOT systems. We want to be able to collect it once and then use the quality data as much as we can to increase its value and actually the savings to the organization overall. Now, one of the first steps in governing data is to establish a set of standard attributes like the ones you see here. Now, this particular set has been in place since 2015 and is currently used to manage over 854,000 assets at ODOT. This particular document itself is currently under review and is being used as a template by our data governance project team to update and create a new set of enterprise standards, as well as to be able to determine data elements that are critical to the business functions at ODOT. We're doing this by taking a look at a number of the primary systems as well as the assets, and then later we'll branch out further into the organization to other data sets as the program itself matures. because we couldn't tackle everything as part of the project, but we do have plans to make sure that we reach out to every business owner. So once this is finalized, we're going to send this list to the Data Governance Committee for approval, and that'll start the implementation of these enterprise standards. Then systems as well as data collections alike will slowly transition to the new standards model as they're either enhanced or introduced to the organization as a new collection. And that new collection could take the form of third-party data, something we've sent out and consulted out. So it's going to take many forms in the way that we manage this. So why not do it all at once? Well, there's a reason behind that. We can't realistically move all of our data standards immediately because it's just not feasible by both funding as well as resource constraints, let alone the downstream impacts of any change that we may make. But by following this strategy, I think that it'll provide us time to both educate and inform our data owners of coming changes to help manage that risk. All right, the Internet of Things is ever changing, and the data that we collect will too. There's undeniable. So the type of data that we collect becomes a moving target at times simply because of the lack of national standards for information that's being transmitted from both cars as well as the smart devices. But even so, it's up to us to make sure that we take care of it all, regardless of the form. Now, we've all heard the phrase, build it and they will come, right? This is actually a real concept at ODOT, but so too is the idea that we have to assume a responsibility to manage the data appropriately so that we can protect the public interest while still providing the best and the safest experience. This is going to come in the form of the data governance policy, as well as the standards and the rules of engagement that we implement as part of our data governance framework. Our own projects here at ODOT include the installation of device towers that we talked about a little bit ago, specifically for the use of others to conduct research for future technologies. So that actually gives Ohio a competitive advantage in being able to manage big data for real-time analytics and performance, kind of like what we're doing with of course, the US 33 corridor project, but also the event streaming platform that's being developed by our own information technology division. In that project, we're assisting the TSMO group by sampling million lines of data at a time, actually per minute, and then stripping out the data we need by putting rules in place to give us the data required to make on-the-fly decisions for both incident management and congestion mitigation. So this allows ODOT and the TSMO group to be able to react quicker and to send out instant messages to vehicles as well as devices, smart boards, and even to personal cell phones if they've signed up with the TSMO group. And that's pretty cool stuff, if you ask me. Now, utilizing AI technologies and cameras, we can actually count people now, just like we do to recognize and count vehicle types, right? So this data is sometimes captured by us, but more than likely captured by a third-party vendor that then sells us the data that we need. So in order to protect ourselves as well as others, it should be anonymous, and it should be secure, and it should be protected at all times during the life cycle of that data, so it doesn't get into the wrong hands and they can't use it to create a break in our privacy. So with that being said, what we're looking for here with the Office of Data Governance is that our job at the office is to partner with each of the business areas in order to make sure that they have the tools and the technology and anything that they need as far as data is concerned to do their job better. And then we simply make sure that that data is not only easily accessible to everyone, but that it's properly managed. And again, that's going to come in the form of our policies and our rules of engagement. So our target or our goal is that we're here to supplement the efforts of the businesses and to minimize any delay in the excellent work they do. So done right, our data governance framework and our new processes should become seamless to our end users, as well as those collecting it. And then as the way that I feel is that we're here to make ODOT even more efficient than we currently are by being able to apply these standards and policy to our framework. And I think that that's a reasonable goal. We've come a long way with what we've done with the asset inventories, and we're applying that experience for those 840,000 assets that we govern with these current standards to apply it to data statewide. So our mission and our goal is simply one little catchphrase. We're managing information to save lives and money at ODOT. So I want to thank you for giving me the opportunity to speak with you guys today, and also about the importance and the benefits of governing data here at ODOT. And with that, I'm going to go ahead and pass control over to our next speaker, Tony, while he's being introduced, and he'll provide you an overview of smart lanes at the DOT.
Thank you very much, John. Excellent. Tony Tarowski is the District 6 planning engineer. He also served as the project manager for the Smart Lane project. Tony started at ODOT in 2008 as a bridge designer, later took on the role as district geotechnical engineer, and is now the planner, starting in 2018. He is a proud graduate of Ohio University, as am I, so it is my pleasure to introduce a fellow Bobcat, Tony Tarowski.
Thank you, Luke. I appreciate the introduction. Also want to thank our previous presenter, John. It's really amazing how much data has come along, even in my career, over about the last 10, 11 years. It's just amazing how much more accessible things are. We do so much good work here at District 6, or at ODOT. I do want to ask, are you seeing my slideshow? Because my presenter view is still showing the OTEC.
No, we're not seeing your slides yet. So if you want to go under sharing, and then under the show button and select the drop-down menu, the screen where you have it displayed.
Thank you, Victoria. I'm watching it reload here.
Yep, we see it now. Thanks.
Great, thank you. For anyone who's not familiar with the Smart Lane, take a whole presentation last OTEC, but in brief, 670 is a corridor in downtown Columbus. It runs from downtown out past the airport and to connect to our outer belt. Very highly urbanized and very congested, particularly inbound in the morning and outbound in the afternoon. Most of the day it functions pretty well, but it would routinely break down every afternoon from about 3 to 7 p.m. So seeing how tightly constricted it was and recognizing how costly it would be to widen it permanently, ODOT looked at some alternative ways to address this issue. And we used some technology to implement Smart Lane. And what that looks like is going to be using the existing footprint of the roadway to basically use that shoulder, as you can see in the upper left-hand part of your screen, bubbled in there, use it as a part-time lane. So we use technology to open and close that lane in the afternoon or when there's an incident or when we're doing construction to push additional traffic through on this corridor. So typically it's 3 lanes out there most of the day, have that shoulder for maintenance. When we need it, we open it up using a variety of technology. Had an interchange project at the east end of this as well to help with improving conditions out there, and we'll talk a little bit about that later. A little bit about the technology that we used. It's pretty extensive. There's about $12.5 million out of the total $66 million value of the project. The big ticket item, or at least the eye-catching item, are 9 large overhead digital mesh signs. So you can kind of see them for scale in the upper left-hand photo, and then the elevation view of them down by the freeway service patrol truck in the lower left. And what these do, they provide a couple pieces of information. Lane control, whether or not the lane you're in is open, they convey that information to the public. Convey speed. Changing the speed out there is pretty important for this project, and we'll talk about what's posted and what we changed over the life of the project. It also can provide some messaging from our TMC, Traffic Management Center, operators out to the public as well. So it conveys a lot. We also have smaller variable speed limit signs spaced in between those. You can see them being tested in the upper right-hand corner. They're meant to mimic our traditional speed limit sign. We have continuous camera coverage out here on the corridor. That's really key for a variety of reasons, both to let the operators see everything that's going on out there and just make sure that there's no issues out in the smart lane while it's open and prior to opening it. We have radar speed detection out there mounted to a lot of these signs. You can kind of make out the cameras on the upper left-hand part of the gantry sign in the lower left-hand corner. We also have speed detection mounted on poles at each one of those installations as well. And a whole lot of fiber to allow all these devices to talk back to our central office EMC. So how did we do? Pretty good. I think most anyone who uses this as a commute will be pretty pleased with how things worked out. Before, the daily trip varied between 10 and 20 minutes on average. And of course, average means you have some stuff that's a lot worse. Afterwards, we're seeing a very consistent 5 to 6 minute daily trip. So that's a really big benefit to the people of Columbus and anyone who's using the corridor daily. I really like to show this next graphic because I think it really paints the picture. What it is a speed scan using INRIX data. And the left-hand side is basically showing speeds across the afternoon period. So we see pretty routinely things are breaking down in the afternoon, traveling speeds below 20 miles an hour. That's not only inconvenient for the public, but dangerous as well as people come up on that queue. To the right is what we have after opening day for the smart lane, which was about a year ago, October of 2019. Seeing a sea of green is pleasing to the eye on this chart and even better out in the field. So I'm pretty happy with that, and that really tells the tale. A little more data, just to illustrate the travel time is the next slide that shows the blue and orange is pre-opening day and green is afterwards. And the reason I show this is there's a little more granular information across the time of the day on the bottom axis. And what I want to just kind of take away here is it was really up and down across the afternoon rush hour. You didn't know what you were going to get. But when you see in the green trend line, it's pretty consistently, it's 5 to 6 minute travel time from 71 out to 70. So that really gives people some predictability of what they're going to experience in the corridor, and that's a good thing. The next graphic is not COVID cases, which is what you might think first. It's actually travel time index. It is a measure of how much time you need to budget for this, this corridor. So if it's 1, you can basically assume that I'm going to leave at 3 p.m. and get to where I want to go at 3:05. I don't have to budget any additional time. And if it's 3, I need to budget 15 minutes to assure that I get out there. So what we've done is made that a lot more predictable. We've flattened the curve. Before that was the hip trend. You can basically count on getting through here on time now. So that's really great results. So with that information, it's good. We had our opening day. We've had some really good results. That was fun, but why else have this presentation other than to pat ourselves on the back? It's actually to share some information on how the smart lanes operated over the first year and take some lessons learned both for future ODOT projects and elsewhere in the country. So I'll compare a few things about what we expected would happen and what actually happened. The largest change was actually the posted speed limit. So 670 was posted 65 miles an hour prior to the smart lane project, and we planned to operate it at 45 miles an hour. And the reason we did that, there are some geometric constraints on the route, and we also expected that even with our improvement, it would still be pretty congested. We didn't expect that people would be out there and they would be able to just travel at free flow speeds. We still expected that there'd be issues. We knew this would be an improvement, but we didn't know that we would actually see opening day speeds averaging about 54 miles an hour. So we kind of imagine people are out there traveling an average of 54 miles an hour. So that means some people are traveling 45 and others are on the other end of the spectrum. They're up at 65. It's a lot better. It's good because we had the interchange improvement and we had the additional capacity from the smart lane. And of course, we designed for a 20-year period of growth. So we haven't experienced that growth yet. So it makes sense that the corridor is performing a little better than we thought. But that still introduces some turbulence. If you have people going 45 in one lane and 65 behind them or later on, that gives us a little bit of concern about safety. So we wanted to look at that and consider, hey, could we raise the speed limit to 55, which is what people seem to want to take out there, travel at. So we revisited some of our assumptions in the design phase. One of the major pinch points was at the horizontal curve going towards 5th Avenue. You can kind of see a roadway view in the upper right-hand corner here. What was going on was it was fine in that condition prior to the project because we had a nice wide 14-foot shoulder. But when the lane is open, you move vehicles closer to the median wall, and they are not able to see objects that might be around that curve. So first thing we did was we went and looked and cracked our L&D manual, went to our horizontal sight distance chart and said, hey, what if we consider the fact that we're coming down off of a hill a little bit? Does that help us see a little bit better that we could maybe increase the speed? It was good in that we could probably see taller objects like taillights from a passenger vehicle. That's good, but probably not good enough for safety's sake. So what we did is we actually added some fixed cameras out there. They could observe that location and make sure that our operators could see that there was no small debris there, you know, a lost bumper or something like that, something that you couldn't see coming around the curve. So by adding a few $1,000 cameras, small expense and big picture of things, we could actually increase the speed and get a little more flow through there. So it's kind of a good chance for technology to mitigate the limitations of the existing footprint. So that was a neat change. Transitioning to the next thing I want to cover was construction activities. Obviously, we had a 1.5-year long project, so we had a lot of experience out there. But really, one of the initial concepts that's always been part of the playbook for Smart Lane was to use it to allow us some flexibility in our work zones. So on the left-hand side, you can see some of the planned messaging that we have for the public when we have workers out there doing preservation work in eastbound 670 or something else like that. The messaging didn't really change. What we found was that we really needed to build up our communications. On a typical ODOT project, the contractor controls the timing. They control the setup and tear down of the signs. And they have the ball. They have contractual restrictions, of course, from us. They can't be closing a lane during the afternoon rush hour. But now with the overhead signs and variable speed limits, we needed a lot tighter interaction between the contractor, the ODOT staff, and the TMC operators, because it would be not good at all if we had a conflict between the lane use signs and the barrels on the ground, or 2 different speed limits. So we developed procedures, plan notes, just to make it more rigorous and to get a really good working relationship between the contractor and our operators. After we got through that, things went pretty well. I think we have a good routine for future projects, and things are going to work out pretty well. But that's a pretty big takeaway, is that you really need to have that positive assurance of what's going on out there and when things are torn down. Normally, if a contractor finishes an hour early, that's no issue, it's bonus. But if they tear down the barrels and don't communicate to the operators, that could be an issue as far as mismatch signage. So that's a pretty important takeaway. Another thing we have is the expected need for sweeping and freeway service patrol. So on the upper left-hand side, you can see one of the dedicated tow trucks that we allocated to the corridor. This is kind of a heavy rig. It's meant to be able to tow something up to the size of a box truck every day. The idea being that they can get out there, they actually drive the route, the shoulder, before it opens up. And if there's something broken down out there, they can remove it and tow it away to another off-ramp or somewhere safe until somebody can recover the vehicle. What we found was that really wasn't happening very much. There just wasn't really a need for it. And in fact, as they're doing their debris sweep prior to opening the Smart Lane, it was really small stuff, and they didn't really have a chance without a tail bed actually put it somewhere. So if you see him, he's actually having to throw it into a closed shoulder until they can send somebody else to pick it up later on. So we changed that out to a more traditional freeway service patrol truck. They're still doing the sweep before every opening, but now they have the ability to clear out the lane. So that was a good tweak, not a huge issue, but a little takeaway. Another thing that's coming up is that we expected to have some situations where the new Smart Lane was not going to be able to be opened because of rain or snow. So what happened was we used to have a nice wide shoulder. We moved traffic 11.5 feet closer to the median wall. So what used to be fine, that could be got a lot of room for ponding water. That's no issue. But when you have cars going towards it, of course, you don't want that situation because of hydroplaning. So during design, we made the conscious decision not to upsize a lot of the storm sewer. We did upsize a few locations, but we really said, hey, if we have like a 5-year storm, that's not very frequent. We can just rely on the operators to observe the conditions out in the field, and if it's wet and ponding, we just don't open it for that day. Same thing with snow storage. So that's what we were expecting, kind of a conscious trade-off for cost. What we experienced was kind of surprising, a very mild winter for Columbus. So we did not have any situations where we did not open the lane for rain or snow. Can't probably rely on that long-term in Ohio. So we'll kind of observe this fall and winter what happens. We'll report out in the future. The last lesson learned I want to share is just a little bit about some of the data we get and how our operators review that and kind of the knowledge they've developed over a year of operation. So what you see is a screen capture from their open TMS software. It brings up a lot of data, speed, density, the conditions out in the field, some of the sign information, and that's all very good and very necessary to manage the situation out on the route. But what we found is that the operators get a good feel for what's going on out there before they really see some of the data changing, or at least concurrently with it, and they can kind of make a prediction of what's going to go on. And one of the big takeaways they brought up was that a lot of the time, as you saw congestion on the on-ramps from 71 and the ramps to and from Leonard Avenue, very beginning of the corridor, as those started to break down or get busy, that would affect the rest of the corridor. So they really honed in on that and observed how those locations were doing. And as those started to break down, they would open up the smart lane proactively before the speed started to drop on the rest of the corridor. So again, this is a situation where the data is helpful, but the operator's knowledge and judgment is key to keeping things running out there. I do want to take this time just to thank the TMC staff. A lot of these lessons learned are from them. It's been really good to work with them. The design, construction, and planning staff, we don't really get a chance to talk with the TMC very much, except maybe when there's a bridge hit, and we get to talk to them a lot, but maybe on a limited topic. So it's been a good chance to work with them, get to know them, learn their perspective and what goes on out in the road, and their input during the design phase and as we led up to opening day and afterwards has been really key to the success of this project. So appreciate their input. I want to share that as anybody else is looking at these installations, we want to make sure you're considering the operators as you work through design and construction. And I'd be remiss if I didn't talk about COVID. I'm sure that's dominated some of the other sessions at OTEC today. But what you've seen is that, of course, volumes took a nosedive in March as we had some stay-at-home orders. And of course, that affected the need for the smart lane to open every afternoon. If we have 50% fewer cars, we're not going to need to open it. So in fact, ODOT has not opened the smart lane due to congestion since March. We've continued to use it for incident management, albeit more infrequently. But I am actually able to share that we're actually gearing up to open it up in the coming weeks. We're actually working through kind of a clean out sweep with our street sweeper and our operations folks. So kind of stay tuned. I expect it to get back into operation as our traffic volumes trend upward. Next steps for future smart lane installations and other TISMO initiatives. We have 2 other locations in the state of Ohio that are coming up. The next one that's going to be moving towards construction in 2022 is the Hamilton 275 project. It's kind of the northeast quadrant of the Cincinnati metro area. And they're going to use a smart lane type installation to provide additional capacity through a pinch point up there. So excited to see that one get built and implemented. And then staying here in Columbus, District 6 is also studying Interstate Route 71 on the north side. Pretty tight area, very built up, has a lot of incidents and slowdowns every day. So we're pretty excited to see how we're able to implement something out there. In closing, I'd like to ask you to vote, and maybe something a little less controversial than the general election, is actually to vote for the American Transportation Awards. Smart Lane is up for a People's Choice Award, and it's open for a couple more days here. What I'd like you to do is to click on the link below, and I think Victoria is going to share it in the chat box a little bit later on, and just travel to their website and please vote for this project. There's not just bragging rights available, but if we win, we are actually going to see a $10,000 donation to COSI here in Columbus. It's a science and industry museum oriented towards children, and if we get that award, that can do a lot good for them. I know they've been hurting from attendance during the COVID event. So I appreciate your time today and for choosing this session. I'll stick around for questions, and I will hand it over to the next person, which should be Nick Hagemeyer. So thank you.
Thank you, Tony. And just to follow up on what Tony said, vote early and vote often, as they used to say in Chicago. You can vote once a day, one vote per device as well. So go out there and help go for that project and help us help co-sign. So Nick Hagemeyer is currently the Managing Director of Infrastructure for DriveOhio. His current duties include development of standards for all infrastructure and vehicle components of connected and automated vehicles to be deployed in the state. He received his degree in electrical engineering from The Ohio State University and has over 18 years of experience in ITS. It is my pleasure to introduce a fellow Western Ohioan, Nick Hagemeyer.
Nick, I think you have your.
Good afternoon, everybody. Thanks,
Yeah.
Luke, and thanks for all the previous presenters. They've had great topics. Sorry, and thanks for all the previous presenters. They've done great at explaining, where Ohio is heading. I'm going to do a deeper dive into the 33 Smart Mobility Corridor. So you can see the 33 corridor is waiting for the screen to update here. Is 35 miles in length, as was said before, reaching from the TRC up in East Liberty down to Dublin. There's been a lot of growth in the manufacturers and auto industry along this corridor. And, we contributed that to some of the activity that's going on. That's the DOT related activity, the Marysville grant that was one the DOT is participating in, and the advancement of the 33 Smart Mobility Corridor. As part of that project, there's been a lot of discussion about the fiber optic cable that's been installed. That cable, reaches from the TRC down to the Metro Data Center in Dublin. It is two redundant rings of 35 miles of 432 strand fiber optic cable. So when, Anthony or Tony talked about 86,000 feet, we are at 100 of fiber on the smart lane. We're at 184,000 feet for this corridor, just in one of those lengths. So you double that, you're in the 360,000 feet of cable. And then, times 432 is the strand count. So really sets us up to do a little bit more of the technology base. Allows us to expand, with the future as technology grows. With the grant project, roadside units were also deployed along the corridor. And you can see the density. This is probably one of the most densely deployed corridors in the nation, maybe even the world. The idea is, from starting out the TRC at the top left, moving down through Marysville, and then on into Dublin. The idea is that a vehicle can travel anywhere on 33 and never lose coverage. You can always, communicate with the infrastructure. Along that corridor, there are also multiple different applications, and some of the applications are a part of the grant project. So you'll see the ones here in black, the reduced speed lane closure warning, focused more around the travel information message that's available today versus the road safety message that'll probably be available in the next couple of years. There's been some advancement there, but it's still in SAE committee. Curb speed warning, we'll focus on those cloverleaf ramps, really giving the motorist an idea of the geometrics of the roadway, what the advisory speed limit is, and then, with the opportunity to grow in the technology for that application as well, as far as, producing an alert for the type of vehicle as well, the vehicle dynamics. So a box truck maybe get a different alert than a sports sedan. I'm going to jump down to the local municipalities next. The pedestrian crossing warning, and we're looking at the personal safety message here, really focused in on the mid-block crossings for the pedestrian application. So not at the signalized intersection where, you have to integrate with the signal phase and timing message, but really focused on those mid-block crossings where there may be a push button that activates flashing beacons or something of that nature, and trying to give advanced warning to the motorists that are driving in that area that, hey, there's pedestrian activity ahead. And then red light violation warning. supported by this signal phase and timing message, that SPAT message. But the red light violation warning, the intent is, to calculate within the vehicle onboard unit, to calculate the speed and the possibility or the probability of a vehicle running the red light and giving a warning to that driver so that they can safely stop if they are reaching those thresholds for not being able to stop in time. And then I want to draw attention back up to the 3 applications in green there. Those are specific DriveOhio applications that we've started to investigate and deploy along the corridor as test applications. And I'll talk about some of these later. But the wrong way vehicle warning, so we did some testing that I'll show in a little bit with Bosch cameras, utilizing video analytics, some of the analytics that John showed in the previous presentation, really looking at vehicles traveling from one detection zone to another, and then producing not a warning for that vehicle specifically, but producing a warning for vehicles in the surrounding area. So we want to make sure that the notice is given to vehicles in the near proximity so that we don't necessarily have to deploy technology like a TMS sign everywhere. We can deploy roadside units and video cameras that are already in the area to sort of provide that function.
Nick, I'm sorry to interrupt, but
yeah.
If you are called in on your phone, could you move your phone closer to where you're speaking? Because we're getting a little bit of distortion. I think it'll help. Go ahead again. Much better.
Okay. So queue warning is exactly what it is. It's notifying the motoring public that there is a queue or a string of vehicles that are either moving slower or stopped ahead of them. And once again, we're utilizing the video analytics along the corridor, mainly right now in between the Post Road exit and Dublin and Avery Road. There's 3 sites that we're sort of testing that application out, and I'll explain a little bit in a minute how that's going to grow. Spot weather warning is another application where we have various sensors at Post Road. That's our main site right now for testing. But utilizing those visibility sensors, those all-in-one sensors that measure wind speed, precipitation, and then using a non-invasive pavement sensor to really focus in on those high wind alerts for truckers, those road conditions as far as ice on the road for everybody, and then visibility. So when fog comes in, how do we give people advance notice? And this is sort of like the test corridor. So we want to test these applications out so that we can deploy them other places within the state, similar to the Lake Effect corridor up in I-90 just east of Cleveland. We want to utilize those visibility sensors and then test out the connected vehicle applications so that we can deploy those applications when the time comes. I'm going to switch over to a video here, so it's kind of show everybody what the signal phase and timing message will be. So before I start the video, you see the green signal up here. You see it on the tablet.
You have to unmute yourself to narrate the video.
This is all V2X communication. All of this is being done wirelessly from the vehicle, from the infrastructure. So you can see, now typically what we would like to see is not to have the motorist get a warning that the right light's going to change to red, not to let them see that countdown, and not to let them see the countdown until when it changes green, but to give them an advance warning that, hey, the red light violation warning is a good application here for signals that are about to change red, and then give them a prepare to for green message when you're within 3 to 5 seconds of the light changing to green, so that people aren't, wasting valuable signal time. While the light's in its signal phase. All right, so I talked about a little bit about video analytics. along the corridor. And I talked about, those 3 sites in Dublin from Post Road to Avery Road. This is the plan for expansion, and these cameras are already out there installed along the corridor. Really focused in on those wrong way applications, those queue applications, and then just getting basic traffic counts for along the corridor. With this being a high test corridor, everybody wants to know what kind of vehicle counts and what kind of vehicle occupant or activity they'll see along the corridor when they're navigating through there. One other application that I will show is the pedestrian application, and you'll see here on the bottom right, or on the right hand side, you'll see the application where the pedestrian is actually noticed here with the red box, and we're actually seeing the pedestrian on the thermal camera down below. And the thermal camera is here.
It muted you again while you were playing the video. Please re-narrate.
Sorry about that. So what actually is happening is the pedestrian is actually moving across the road. The video camera is actually picking that pedestrian up, sending its metadata to a device within the cabinet, and then let me just replay that. And then it's actually
It muted you again.
it's actually broadcasting that out to the vehicles via the V2X communication. I'm going to switch back over here to the screen and talk about the wrong way warning application, and it should pop up here in just a second. So we did some wrong way testing on 33 at Post Road, utilizing one of the fixed thermal cameras and a PTZ camera there. And what we did was we set, if you can see my mouse here, we set up two or three detection zones, 2 in the green on the bottom right, and then the 1 in the red that's just halfway down the ramp. And the first detection zone actually triggers when it notices anything moving in the wrong direction on that ramp. So once that triggers, it's like the first instance of detection. And then we want a redundant detection mechanism. So the second actually triggers again if it notices something moving in the wrong direction, but it has to be classified as a vehicle, a truck, a bike, a car. And then once that happens, it actually triggers a PTZ camera to move to the red square, the area of the red detection zone, and it'll track the vehicle all the way up the ramp. We did this and we were fairly successful. MIC tracking was one of those things that, and the MIC is the type of camera, the model of the camera of Bosch. One of the things with the vehicle tracking is, the speed and other vehicles traveling in the right direction kind of, can interfere with the tracking of the wrong way vehicle because it tracks the vehicle with the highest resolution or the biggest object. So one thing that we can get out of this is verification that a vehicle did drive up the ramp the wrong way. I'm just going to talk about this when we're running a little short on time, but essentially, you can see the screen here. This is an example of what a queue warning application would look like. So as this vehicle, there's a roadside unit at Post Road and 33. So as this vehicle travels eastbound on 33 and it travels up towards Dublin, you go around a blind curve, and usually there's some traffic back up there from 270. So in this instance, we're getting a slow traffic ahead, and it's also giving some SPAT information there, some signal phase and timing up in the top left for the signals that are in the area. So it did associate us with a signal there. It looks like maybe the Avery Road maybe reached there as well. And that's really all of my presentation. You can see with all the testing that's going on along the corridor, both on the ground and in the air, and kind of tying in John Puente's data initiatives, we're really trying to make this the corridor where everything's tested and all of these use cases are proved out. Thank you.
Thank you, Nick. Hey, Victoria, do we have a hard stop at 3 o'clock?
We do not. So you can feel free to start reading questions if you would like.
I will. Well, first of all, I want to thank everyone that presented today and all of you for joining us. This is always, I'm blown away by the innovation, the partnership, and the outside, thinking outside the box when it comes to these initiatives here at ODOT. And I guess the first question that I would pose to the group is, all of these deployments are innovative. During your project, either design, deployment, bringing it from paper to fruition, what was the secret of the innovation? So we can start with Howard and just go down the line.
Make sure to unmute yourselves before you start speaking.
Really not fair, because I've only been on the job a month and a half, and so you're just putting me on the spot, Luke. I would just throw in that leadership is very important to foster these things. I think that's true for DriveOhio or any other of these initiatives. They have to have support from top leadership, and I think ODOT leadership and Governor DeWine are very supportive of advancing technology in Ohio, and I think it spills over into our programs.
You can go next. Fred, you can go next.
Is that me?
Yeah, you're good. We can't hear you, Fred.
Sure. So this is Nick. I'll kind of just chime in there. I think
Hey, go ahead, Nick.
All right. Yeah. So I can just chime in. I think the key to innovation is having those partner relationships with the industry. We can't do this alone. I think industry, has recognized that they can't do it without the infrastructure owners, operators, and we can't do it without them. So meeting them in the middle, trying to give them the tools that they need to be successful, as well as learn, what their challenges are, so that we can help them achieve success.
Excellent. Fred, did you want to try to join the conversation?
Fred, we need you to unmute yourself, please.
Can you guys hear me now?
John?
Yay, we can hear you now.
Okay, here we go. That was double muted. I apologize for that. You definitely need state buy-in for any of these programs, as we move forward. Buy-in is key, and I always look to Howard to help us out with that. So, yeah.
Yeah, thanks, Luke. I would say from a smart lane perspective, we had a lot of good opportunities to benchmark against other states. We got to talk with some FHWA resource staff and just kind of see how did things go elsewhere, and learn from their, I won't say mistakes, but learn from their issues and try to build on that. So that was really key. I want to echo what Nick said. Reaching out to industry ahead of time during development, both from a vendor standpoint and from our construction staff, added a lot of value. On our consultant staff, we had somebody that used to do ITS work in Philadelphia on the design side. We had a vendor day with all the different technology to understand what was viable, what was cost effective, help us make decisions along the way, and refine our expectations. that was really good and good valuable input. So.
And John. Hey, John, I think you're muted.
You're not muted in the system, so it must be on your headset.
How are we now? Good. Okay, so I think for me, it's kind of twofold. The first one is the buy-in from the administration to allow us the ability to go out and become experts at what we do. They've given us the ability to not only research technology, but also to introduce it to ODOT and provide a good benefit, right? And the second part of that is the talent that we have here at ODOT. We've been able to partner not only with local government agencies and with vendors, as well as with other state DOTs, but we've also been able, on my part, to build a good partnership with each one of the business areas within ODOT. And I think that that's a key to success for anything that we do.
Excellent. And Howard kind of touched on this. You know, it all starts with leadership. And from our perspective, that comes from the DeWine Houston administration, and that flows to our director, Jack Marchbanks. And I've heard Director Marchbanks talk about, you know, there's a paradigm shift currently underway in the transportation system. How do you guys see that change, and how do you think that change will manifest itself over the next 2 to 3 years? Where do you think the technology piece, the smart mobility, the smart transportation, where do you think we'll be in 2 to 5 years? I'll start with Nick. I have to put you on the spot. And Nick, you're muted.
All right.
There we go.
Where do I think we'll be in 2 to 5 years? Shouldn't be. Okay. In 2 to 5 years, I think we'll be a lot further along with our data initiatives, utilizing data to be more proactive rather than reactive. I think right now, you know, with our traffic management, with a lot of our ODOT operations, we do a lot of things reactively after we figure out that things have happened. I think, you know, we'll be creating algorithms and insights to let us know when things are, you know, most likely to happen, so that we can take proactive measures to kind of keep those from not happening, or, you know, minimize the reaction or the impact.
Excellent. We'll just go down the line from my screen, and I apologize. We'll go Tony, John, Fred, and then Howard.
Yeah, I think from a narrow perspective, from some of the, you know, maybe not as new technology as the other DriveOhio initiatives, but like I said, I'm hopeful that we've continued to operate the smart lane and continued to refine what we're doing out there and incorporate those lessons into the other 2 corridors that I highlighted. I think at that point we'll be hopefully where Hamilton 275 is opened, and we can see how another set of drivers interact with the technology and see how TMC is able to scale operations on their end. You know, they added a dedicated staff member to watch the actively managed corridors. There's another variable speed limit corridor up on Lake 90. It's another DriveOhio initiative. So having somebody dedicated there and training up some of the other staff is key. I'm hopeful that within the next 5 years, everybody's learned a little bit and gotten better and kind of able to learn what we need to do for the next job.
And for me, I think the maturity of machine learning and the AI technology, I think that is going to play a big part into what we can provide to our customers. The real-time analytics that we need to perform now on vast amounts of data is extreme now, but it's going to be even more effective as we move forward into the next 5 years because of the technology behind it. We'll be able to produce quicker responses to our customer and provide much better quality to the data that we're and information that we provide them.
My turn. You guys can hear me? So 2 to 5 is exciting. So next year, you're going to see last mile package delivery start to take place with unmanned aircraft. As you go a little bit further into the future, we'll see these like pop up in the rest of the urban centers. When we look at the larger aircraft technology, so we move into people movement and logistics, and we start getting into what's called vertiports to support all this new technology. You know, the state of Ohio is looking at charging infrastructure for all the electric vertical landing takeoff aircraft. So you're going to start seeing these charging stations pop up at airports and other locations. So I'm saying, you know, we are already testing the movement of people with the new flying car concepts in SkyVision. I'm saying we'll see those starting out with as a piloted aircraft with the option to be optionally piloted, and we'll see these things start in the next three to 5 years. You're going to see that technology start to infiltrate into the rest of Ohio. So I think the next 5 years for at least the aviation side is going to be extremely exciting, and happy to support all those new, all the new aircraft technologies in the airspace.
Yeah, so Fred, I really agree that the third dimension where Fred operates in the sky is really open and ripe for development. And there's a lot of private sector activity that's going to finance that development with aircraft in that, you know, under 1,000 foot airspace. And then on the ground, you know, there's tremendous investment into vehicle technology and data, and that's going to continue. Our challenge is going to be in 2 to 3 years. We're going to be sort of in the same place unless there's action legislatively, and that is we're very resource constrained. And so any of us on this panel, and I just think of John and his systems, you know, if he had an unlimited budget, he'd do a lot more, and John's budget is not unlimited. And it's the same for all of us. And so those challenges, I don't see that changing in 2 to 3 years, which is unfortunate because, you know, the revolution is possible with vehicle technology, but there's going to have to be, I believe, a different funding model for surface transportation, which we haven't had that really emerge yet from our federal leaders. And, you know, we're just beginning to contemplate things like, what does it mean when EV charging becomes a bigger issue, when electric vehicles are really a bigger part of the market? That's going to create more challenges that we'll have to address.
Well, excellent perspectives. So we have a large and vast audience, and I wanted to get your gentleman's perspective on the role, and Howard kind of touched on it with maybe some of the budget stuff. What role can regions and then local communities play as we develop and deploy these systems? We'll go in that same order: Nick, Tony, John, Fred, and Howard.
So I think Howard touched on this a little earlier. As we're developing the standards that the rest of the state, locals all the way up to, you know, regions, as we're developing those standards, that'll be on their part to kind of adapt to those standards and embrace them, so that, you know, we can continue the growth in Ohio.
Luke, I apologize. Could you repeat that? You cut out for me.
Yeah, just the importance of local communities as we're developing and deploying these systems. What is their role in smart mobility and smart transportation?
Yeah, I think that's a good question. You know, from the smart lane perspective, you know, it was a freeway-driven project, but obviously it greatly affects the communities it goes through in their local system. So really focusing on outreach was key, and getting their buy-in going forward is always important. And that really just kind of taking the perspective that nothing we do is in a vacuum. Ohio the public doesn't see boundaries. They don't care if it's the ODOT to Columbus maintenance responsibility ends at the Gore or whatever. They want a seamless experience and they want to see everything consistent and just want the best product. So I think most of the professionals and people in public service and in the community and the industry want to give them that. So just trying to take the customer perspective and try to work together.
I think for me, one of the things we need to be cognizant of is the budgets that the locals have. So as ODOT, we need to be able to provide the tools and technologies as much as we can to our locals in order for them to be able to participate. So one example is if we're collecting asset information with an infrastructure that we already have, can we provide them the means to add their data within our structure so they can take advantage of the tools that we've developed also?
All right, so on the air side, my perspective, when you're going to what we're calling a vertiport, I mean, it's a vertical landing takeoff location, right? So if you look at it from that perspective, it's basically a helipad, but with some level of autonomy tied to it, and the volume that's expected that these things are going to be able to handle is going to be a lot different. So, when you look at the local perspectives and what kind of information or help we will need for that is pretty much the same as if you're going to locate a helipad. Some of the differences, though, is that a lot of these vertical landing takeoff aircraft, while there's some hybrid solutions out there, we're mostly concentrated on electric, and electric is a lot quieter as far as the noise profile is concerned. So there's going to be some work, and we've begun outreach to different zoning officials as far as what kind of impacts they will have on local communities if you do enable this new mode of transportation. And it is something that we're working with our local officials. We're also working with NASA and trying to come to some sort of consensus on if a vertical landing takeoff location is going to be located on top of a parking garage. What parking garage is it safe not only to the ground, what's on the ground, but also is it safe in the air, and how do we implement that? And then what kind of noise impacts will there be if depending on the type of aircraft that lands there. So it's definitely at least on the air side, we have to go together, go forward with this together, and something that we're cognizant of and are reaching out to.
Yeah, thanks, Fred and Luke. So the role of the locals, the answer is it's critical. It's obvious because our trips begin probably on a local street and go to an arterial, and maybe sometimes to a freeway, maybe not. But all these systems are interconnected, which is the same need, obviously, for connected and automated vehicles. So then you turn to our partners have been, ahead of us at times, like Smart Columbus, received the grant before DriveOhio was in existence, and their technical folks and their leadership are developing those the smart signal technology and in the midst or on the cusp of testing it. So that's a great example. And then to tie it back to Nick. Nick Hagemeyer led our systems engineering analysis for CAV, and that had an extensive local outreach to MPOs, for example. And that work is, I'd say, not as interesting as a driverless car going down the road, but it is the work that we do that's critical, and we have to maybe publicize that better for our local partners. But that kind of work is what's going to make all these systems function and operate together. And yes, MPOs and local governments have been critical in that effort so far.
Excellent. I think one of the through lines that I picked up on everyone's answer is the ability to provide public value and increase the quality of life of our citizens across the state of Ohio. And I think that's a good, the questions that have come in, we've answered throughout the wide-ranging discussion that we have had. We're about 10 minutes overdue. I do want to thank Victoria and Paula for their assistance getting this all set up. My lack of technical acumen didn't come in by me in the bottom too bad, so I appreciate all the support. Before we head off, does anyone have any final questions or comments that they want to leave with the group?
Oh, you're talking the panel, Luke?
Yeah, absolutely. Yep.
No, I'll just do my favorite Jack Marchbanks and say, stay safe, everyone.
Excellent. Well, again, thank you for your participation. A lot of innovation, a lot of great things coming from the Ohio Department of Transportation, DriveOhio, and the Ohio UAS Center. So with that, I bid you a fond afternoon. Thank you.
Thank you, guys.
Everyone.